Hey, what's up guys? Jeremy here from RoboDK. Welcome to this new tutorial. Today, we will use our new plugin for Fusion 360. This new plugin unlocks for our Fusion 360 users a feature that we call CAD to Path. In a few words, you can create your robot path in Fusion 360 and export them in RoboDK. For this tutorial, we will replicate this example. A Fanuc robot bringing a car windshield to a dispensing system and applying adhesive on the glass surface. Considering that the robot is holding the windshield, this situation is a bit special. It's called a remote TCP situation. It's called this way because the TCP, or tool center point, is not fixed on the robot as is usually the case, but rather fixed somewhere on the station. In our case, it's at the tip of the dispensing tool. This kind of situation is almost impossible to manage without an offline programming software like ours. We could even say that it's now simple with our Fusion 360 plugin. Let's check it out. In this tutorial, we will start from this station. My equipment is already in place, so my Fanuc arm is there with a special vacuum gripper. I also have the adhesive dispensing tool. If I unhide the reference frame glue in my station tree, I can see the TCP of this project. I'll let it visible for the moment. Simply note that the blue arrow representing the Z-axis is pointing in the direction of the adhesive flow. The pick-and-place programs for the windshield are already built. If I run the main program right now, it will simply take the windshield from the first pallet to the second one. Let's press escape to stop the simulation. Now I can activate my little replace objects program that will simply return everything at their original position. I create one for every single pick and place project, and you should honestly do the same. It only contains one instruction, an event set object position, and it replaces the object at their last recorded position. Very useful when your goal is to move objects around. If I open the main program, I can see that it's the same sequence repeated 5 times. So pick a windshield, run the subroutine dispensing, and place the windshield on its finished pallet. At the moment, the dispensing subroutine is empty. So it's not doing anything, but we will solve that problem. Let's delete the subroutine and open Fusion 360. So here I have the 3D model of my windshield. On top of it, I created a sketch, and on that sketch I drew the pink line you can see here. I can highlight it by selecting the sketch. This line shows where the adhesive should be placed on the windshield. In other words, it's our toolpath and we want to export that in RoboDK. For the 3D modeling part, I won't show you how to draw that line. It's not a Fusion 360 tutorial, but I will give you the main steps. Simply put, you need to create a first sketch flat here. Then you need to project the exterior of the windshield on it. You then offset that line towards the center of the part, in this case the windshield. And finally, you project that line back on the surface of the glass. You should end up with that kind of path. If you guys already know Fusion, this should be the easy part. And it's pretty much our goal. Keep as much of the work possible in the software you already know. Now, let's jump in the important part. How to export that path from Fusion 360 and import it in RoboDK. First, you need to make sure that RoboDK's plugin is installed and activated. If you see the RoboDK icon in the Model tab, your plugin is working properly. If not, refer yourself to the installation documentation. Let's look at the options the plugin offers. First, we have the Auto Setup. If you use it, you will import the path and the part. The 3 other options go as follows. Load only the 3D model of the part, load only the path, or load only the drilling points. The 2 other options are for CAM projects and will be covered in a future video. The last option lets you access the import settings. You can use it to enter some presets, but it's not required. This window will still pop up when you activate some options if needed. We already have our windshield model imported in RoboDK, so no need to import them again. We will only concentrate on the path for this example. To do that, we will select the Load Curves option. This little setting window will pop up. First tab, what do I need to do? I need to select the points, curves, and faces needed to generate the path. In this case, I don't need any points. Those will only be useful for drilling projects. Now for the curves. The curves are the features of your 3D model you want to follow as a robot path. It can be a sketch, exactly like we will do in this example, or it can be an edge of the part. As I already said, the path we will follow is the pink line, so sketch 12. So I can click on the select related to the curves option, and I can start selecting the pink lines. Okay. Generally, the first line you selected will become the first path to be executed by the robot. If you made a mistake, don't worry, it can be modified inside RoboDK. Okay, now that we selected our path, there's still the faces option. This one is as important as the curves one. By selecting faces, you will give RoboDK the information it needs to calculate the orientation of the tool. It will always try to match the z-axis of the tool with the normal to the surface. In our example, we want the dispensing tool to be normal to the glass surface. So we will select the surfaces underneath the path. This one and this one. Okay, perfect. Now in the Basic Settings tab, we can give a name to that path. Object name, let's say dispensing path. Okay, perfect. Now we can click OK and go back to RoboDK. We can see in the middle of the station that a new reference frame was created. It's called Part Reference and it contains the path we just imported, dispensing path. Obviously, I don't want the path to be there. Like I said in the beginning of the video, we have a remote TCP situation, therefore the path needs to be mounted on the robot flange. To do so, I simply need to drag and drop the path on the robot in my station tree. Pretty straightforward. Now that it's done, the path is attached to the robot. But as you can see, it's not quite at the right place and quite in the right orientation with respect to the tool. To fix that, double-click the path and select More Options. If you remember well from the Basic Guide series and from the 2 videos I created about the tool, this is where you can modify the origin of an object. Considering that I designed the suction cup tool myself, I know exactly where the windshield path should be placed. Let's do that real quick. 61 degrees around Y, minus 230 millimeters along X, and finally minus 190 millimeters along Z. Let's apply those modifications. Like I said, those measurements came from the design of the tool. You should be able to extract the same kind of data from your 3D model. We can quickly take the time to delete the part reference. It was automatically created when we imported the path from Fusion 360. Okay, now let's set up our robot project. As it's the case for every one of our plugins, a curve follow project was automatically created when we imported our path. In the setting window, we have a few things to adjust. First, the robot, that's our Fanuc, so that's okay. Below that, we have our reference frame. This option is very important in a remote TCP situation like ours. Here, we need to select the reference frame that represents our fixed tool. In our case, it's the glue reference frame. I can select it from the drop-down menu. Okay. And for the tool, use the path you just imported. So, dispensing path. Now there's another very important setting to change. In the Select Algorithm section, change the standard minimum tool orientation change for the robot holds object. Let's say that the name of this option is pretty straightforward. Now, if we update, we should have a green check mark. Here we go. At this point, I recommend you to uncheck the auto update option. Now we can simulate. The robot is following the path exactly like if it has the windshield attached to its tool. But there's still a problem. Let me grab the slider. Considering the orientation of the path, and therefore of the windshield, a collision occurs in this section of the program. If the path was simply rotated 90 degrees, that would fit. Let's toss the curve follow project on the side for a second and open the robot panel. I simply want to rotate the tool, so in the jog section, select rotation around Z. Now rotate in the direction you prefer. So this looks good. Now back to the curve follow project window. I will click the Teach button just beside the robot holds object option. This option will record the actual orientation of the tool and try to match that with the path. Note that it only works with the rotation around Z. Now if I update and simulate, with the path in this orientation, we should avoid any collision with the equipment. Perfect. Close the robot panel, and same for the curve project. Now, the curve follow project automatically created a RoboDK program called dispensing. Therefore, if I simply launch the main program, it will call the dispensing program in between each pick. Let's try that. Okay, we pick, then we apply the adhesive. Then we put the windshield on the finished pallet. Nice. It's working like we expected. Okay, now we need to generate the actual LS file that will be sent to the robot controller. Right-click the dispensing program and select Generate Robot Program. A little window will appear with the program in text format. You can then save this LS file and transfer it to your robot controller. Okay, that's pretty much everything for today's video. I really hope you liked it. If you did, don't forget to subscribe to our YouTube channel. We are always releasing new videos covering RoboDK's features and tricks. Have a good day, guys.